Hello guys, welcome back to another Fall Position video. Today we will be at another question here, and as always, let's first start by reading the question. So, Bob and Jane hold identical decks of 12 cards, 3 of each color of red, green, yellow, and blue. Bob and Jane shuffle their decks and then take turns dealing one card at a time onto a pile, with Jane going first. Find the probability that Jane deals all her red cards, before Bob deals any of his red cards. So, and they actually have to give their answer in the form of a fraction in lowest terms. Now we can see here in these decks there's 4 colors: red, green, yellow, and blue. However, I can also just say that there's 2 colors, 3 red and a 9 of the same color, let's just say black or like yellow. Because those don't really matter anymore. They only care about the other colors other than green, yellow, or blue, or other than the fact that there's X amount of cards that aren't red. So let's consider a sequence of 24 positions. So let's say I'm going to draw out a couple of spaces here. And let's say there's 24 of these spaces, okay? Let's just keep on going. I'm not going to write all of these out, for example, because, yeah. So let's say we have a bunch of these spaces. So we can then say that the first position, so like the positions 1, 3, and 5, we can say that these are Jane's moves, and that the even positions, so for example 2, 4, and 6, and so on, could be Bob's. So let's say we put down, so let's just say that we put down all 3 of Jane's red cards in this sequence. So obviously there would be 24 of these, right? And then in Jane's, so all the odd ones, we can label out which cards are put out in this certain sequence. And we can see that the rightmost position of Jane's one. So the last, the last red that Jane puts out in her sequence, right? There should be none of Bob's reds before that, okay? So as we can see here, we can see that what if we put Jane's last red card in the 5th position? Well, we know that her other red cards, there's only 2 positions here, 1 and 3, and we know that the rest of Bob's cards, the rest of Bob's red cards, they have to be past Jane's red card in the sequence, and so on. And so the answer to this problem is actually kind of long. It's just going to be, So for example, for that first scenario that I just mentioned, let's say that Jane somehow manages to pull all her red cards in a row, and she gets them all out super quickly. Okay, this means that her last red card she puts down would be in the 5th position or her 3rd turn. Okay, this means that the other 2 red cards she deals before the last one would have to be in the remaining 2 spaces. So in the remaining 2 spaces, there would be she needs to put down 2 cards or 2 choose 2. And then after this, we see that after Jane's 3rd turn, we see that Bob only has 10 turns left, okay? And he needs to put down all of his red cards in those 10 turns. The other colors don't really matter here. So we see that for him, it would be until all those 10 spaces, and we need to choose 3 spots to put red cards in. And this will continue for the rest of it. So let's say instead of Jane putting her last red card on her 3rd turn, it would be her 4th turn. Well, this means that now there's 3 spaces to put her red card, to put her 2 red cards, and obviously she has 2 red cards. And because Jane put her red card 1 turn later than last time, this means that Bob now has less positions to put his 3 red cards, and so on. So obviously we need to do this for all positions that Jane's last red card could be in. So I'm just gonna write these all out. As you can see here, they all follow a sort of pattern, where there's one more position for Jane's cards, and then one less position for Bob's cards. This is actually going to wrap onto another line. So as you can see here, while I'm talking about this, the key of this means that the answer to this problem is just going to be this really long sequence of numbers added together and multiplied together. Oh, sorry, I keep on writing. Yeah. Alright, so we're almost done here. Yeah, so I'm gonna explain what I just wrote down. So as I said before, we have this is the first sort of like scenario where Jane's last card is in the 3rd position, and so she has she has the 2 turns before to put her red cards in, and after that we keep on saying, okay, what if her last red card is on her fourth turn, or her fifth turn, or her sixth turn, and so on, all the way to her final turn. Okay, so the 12th turn, and then we see how many places can Bob put his red cards now, with Jane's last red card being in this position, and how many positions can we put Jane's remaining 2 cards in front of it. So this is going to be equal to, right? You can see here, 2 choose 2, that's 1, and 10 choose 3, that's 120, right? So you have to solve this all out, and you have to multiply them together. So this is mainly just like a computing question, right? So this turns into, we can expand all of these numbers into this. It's going to be kind of messy, but... So as you can see here, this long sequence of numbers turns into 1 times 120, plus 3 times 84, plus 6 times 56, plus 10 times 35, plus 20 times 15, plus 21 times 10, plus 28 times 4, and finally plus 36 times 1. And this is going to be equal to 1,716. So the answer to this problem, so not the answer yet, we know that there's a total of 1,716 sequences where this happens, where Jane gets all her red cards before Bob even puts down one of his. So how many total possibilities are there? Well, we can see here that going back to a sequence here, we know that there's 24 total positions, and both Jane and Bob both have 12 each. Okay? As I said before, the only thing we really care about are the red cards. All the other cards don't really matter what color they are. So this means that total number of possibilities has to be 12 choose 2 times 12 choose, not choose 2, 12 choose 3 times 12 choose 3, or 12 choose 3 squared. This is because for each of these guys and their 12 turns, we just need to find out where they put their red cards. This means that the total answer to this problem should be, so the answer should be on the denominator, so the total amount of cards, we have 12 choose 3 squared, and then on top, we have 1,716, which I just solved. Now 12 choose 3 is equal to 220, right? So this turns into this, 1,716 divided by 220 squared, which turns into 1,716 divided by 48,400. Then obviously we need to simplify this into 39 divided by 1,100. So the answer to this problem is going to be 39 divided by 1,100. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye!